draws the radius of a circle. So you imagine if that makes sense. Yeah. Okay, so this is the radius of the circle. All right.
It's the wrong way around.
It is wrong. Yes, I noticed that. Oh, yeah. Sorry. Can we do it right
No,
around?
it's okay.
Yeah. Write the radius. Write the radius circle can be drawn in terms of theta. The radius that could be drawn in terms of theta. So we got a 9 and an 8 here. So we'll just go back to the triangle. 9 and 8, and theta here in the middle. What are we thinking? Cosine rule. Yes. So r squared is equal to 9 squared plus 8 squared plus 2 minus 9 times 8 cosine theta. Write the radius in terms of theta. Well, you gotta have. Yeah. So probably could tidy this up a little bit. Maybe what's 9 squared plus 8 squared? Quick maths.
81 plus 64.
Yeah.
145.
Okay, faster than you in your calculation.
What's 2 times 9 times 8?
Use the tools.
72. 144.
Oh, that's pretty fast.
That was pretty good, Mira.
Yeah.
Thank you.
All right, we're there. Yes. Plus minus?
Yeah,
Yeah.
because it's a square root.
Oh, yeah.
No, radius.
Oh.
Yeah.
Don't even think about it, girl.
You got there.
Great, you got yourself bonus.
Hence, find the rate of change.
Cancel
All
that
right,
one.
the rate of change in the radius with respect to theta when theta is 60.
Cos 60 is 2 root 2.
Rate of change, though.
Hence, find the
Oh,
change.
differentiate with respect to theta.
So rate of change would be, yeah, d or d theta. The rate of change. And it's in the calculus paper, so we expect, or the chapter, so we expect calculus to occur. We have to do something.
So then change.
Differentiated.
Right, differentiate it. So let's do a little rewrite here. Maybe that will help. 145 minus 144 cos theta to the power of a half, maybe. Will help me here.
Sure.
So we use our old buddy chain rule.
You really want to.
I do.
Negative a
Multiply by what?
half.
144.
Oh, to the
Negative.
power first, yeah. Negative a half.
And then multiply.
144
Plus.
No, it's positive. 144 something.
Yeah.
It is positive, yeah, because
The cos
cosine.
isn't like the sine, but the sine like
Very
the
good.
cos.
Okay, so I could have this, maybe I like this as, yeah, I like 72 sine theta, like I'm thinking all over the root of 145 minus 144 cos theta. Do we like that?
Yeah.
Are you allowed to calc for this?
I think yes, but what we need to do now, so theta, so is this theta radians or degrees in calculus?
Degrees.
Which do we use, radians
Oh,
or degrees?
radians.
Oh, so here's
You
the
can actually use
degrees.
whatever you want.
So it's pi over 3.
It's always radians. Always radians when we deal with
I
calculus.
love that
Always.
was in like hospital.
Huh? Oh, in calculus, just go. It's always in radians. We deal with radians with these functions, and then afterwards you can interpret the answer into degrees if you want to convert an answer. So this is a radians function. So that means, what's sine 60 degrees?
Root 3 over 2.
Root 3 by 2.
So you can think of it still in degrees, but you'll get the same answer. So that's root 3 over 2.
Interesting.
And sine 60 and converting it to radians will give the same. I'm talking about interpreting. Now the answer you probably give it both ways as well. And that is 145 minus 72. Okay, yeah, you're going to need a calculator for this. That's not a nice square root, is it?
Thank you, bro.
Can you just
So
leave
leave
the
it.
room?
You probably could tidy it up a little bit. So this 36 root 3 all over
Root 73.
root 7.
I have the answer.
Root 7. You have an answer? What is
Yeah.
it?
10.3.
Wait, is that just for the bottom square root or for the whole thing?
Doesn't look like 10.3 to me.
Whoa.
It could be, could be.
7.297.
Right.
7.297.
Redo it.
7.29?
It's my trusty Casio.
Mine is rotting. It's not coming up.
Oh, you got it. Alright.
12.6.
For the whole thing?
So are
I do
you
have the answer here.
using
Hold
one
up.
or
Now I times it by 3. Give me 3.
Bro, let me do it.
Maybe
It's
you
7.297.
Yeah, I got that now.
7.297.
Yes. Did you do that? Was that like quick math? Mental math.
Yeah, 7.29. Yes. That's 7. Did you do it? No, no one did it in their head.
Wait,
Yeah,
who did you do it in your head? Who gave 7.297?
That was the first. Right. All right. What's that mean?
It changes with the rate. The radius changes with a rate of 7.297, like I guess centimeters at 60 degrees.
So yeah. So if we rounded three significant figures, it'd be 7.380, I suppose. So say that again first.
So like the radius changes at a rate of 7.3 centimeters at 60 pi by 3.
At a rate of 7.3 centimeters per.
Oh, greater degree per radian.
minute.
Per radian, yeah.
So you don't have your microphone on.
Oh, I don't. It's down here. Sorry. Probably picked up most of that. Put it on now. Okay. So the radius changes per radian. Okay. Second one.
Okay, let's go.
Wait, so do we learn multivariable calculus?
Multivariable calculus. Like what?
Like the mini sigma sign with like different x, y, z. Kind of like
No.
vector products, I guess.
Okay, so we have that one done. Infinitely many rectangles can be inscribed in a set. Wow. Don't even understand what that means. Someone's going to have to explain that to me.
Oh,
That's a semicircle.
That is a semicircle. Good. That's step one. What's that? Half a circle?
you can keep fitting them in the holes.
What is in?
Keep fitting it in the
Infinitely many rectangles can be inscribed in a semicircle of diameter. So, excuse me, many rectangles.
But
And
you
you
have
Many
to find
rectangles.
The biggest rectangle.
Is this okay?
No,
No,
it's
like
the
all
one
the edges
there.
touch.
Oh, it's got to touch the edge. Oh, inscribe means when it touches the edges, yeah?
The one that's being drawn on the thing is the one I was.
So there's one, and maybe there's two, yeah?
There's one in the middle.
No?
It's actually infinitely many.
There's actually infinitely many. So that's what I'm trying to get is there's loads of rectangles that can be drawn.
That's the ultimate one.
That's probably the king, yeah. But which is the one with the maximum area?
Okay, I guess we can.
You're gonna have to use a little bit of calculus, I think. So.
That's the problem, yeah. So do we understand the problem a little bit more now, maybe? Yeah. Okay, so we got a bunch. Let's stick with the one diagram rather than that one. Let's just take a generic one. Now what? Diameter is 20. I know that. Great.
So we name the left side and the right side X.
Yeah.
Yeah.
The left side of what?
Nor the one on the left side of the rectangle, the small little space in the small.
Oh, this little gap here?
Yeah.
Well, we're going to be dealing with the area of that rectangle. I'm not sure we need this to be x. Well, we could, I suppose if we did find that, we would have the area as well. Is there any
Radius is 10.
radius is 10? Where can I draw the radius here?
Oh,
Where-
so
The radius.
Here?
Oh, to the corner of the
Yeah. That's 10. That's 10.
Oh, I bet you.
Oh,
Yeah. I see.
What will I call x?
The
oh
X
like
is
some,
like opposite.
some trigonometry.
I have a choice, either this dimension or this dimension called x.
opposite.
This one, x. Right, that means I need this one now.
10 minus x. Wait, what?
Wait,
Wait,
no,
why
it's
is
like
this one? Wait,
10 squared.
You told me that
x
one.
squared.
I agree with
10 squared minus x squared.
Root
is
10
equal
squared
to-
minus
So Pythagoras theorem would have this side as 10 squared minus x squared square root, yeah?
Yeah.
Okay, I'll just get rid of this. I don't need this anymore. So this is root 10 squared 100 minus x squared. We happy with that?
Yeah.
Yeah.
2 times that would be this length, yeah.
Yeah.
So what's the area?
So 2 times that times x. Wait, this is so aura.
Why?
It's so cool.
So that is
No, it's not.
2x. Can we get the square root of that?
Huh? Oh yeah, it's to the power at 1/2 in the product rule.
Oh, so you wouldn't just write 10 minus x?
No, that's not allowed.
That's smart.
I'm trying to trick you, yeah.
Why can't you do that?
Well, that if you said that, that would mean 10 minus x squared is 100 minus x squared, which is a mistake you made earlier on. That's not true, because you got that middle term that you forgot. Yep. Okay, so what do we need to do? So that's the general areas. That's all the areas it possibly could be. So we want to find where that area is max, yeah? So we need the derivative of this. So that's a. We need dA dx, I suppose. As x changes, what's a? You're right, probably product rule would be easiest thing to do here. The first, maybe I'll write this with a half.
2 half 100 minus x.
We don't need product.
So X.
Because there's two things here, yeah?
Yeah.
So first, I'll do first by derivative second, just cause.
1 over 2 minus x squared. Wow, you get 1 over 2 times.
Are we happy with that?
You so quick with it.
And then
Plus
plus,
2
yeah, 2, yeah, 100. Okay, not too bad. I think this 2 and this half is going to cancel anyway.
Ooh, yeah.
Let's see, can we do this with a calculator? I feel like a calculator's on horizon here.
Horizon.
Could we like do it without a calc?
Yeah, let's do it without.
You try. I'll try too. You can try with a calc if you have one. I'll do a rewrite here. So
Yeah, that's a good.
I think I've got a minus 2x squared all over square root 100 minus x squared from this one. And then I have plus 2 root 100 minus x squared. So what does the derivative have to equal?
Huh?
That's the derivative. What do I do? Okay.
I do it now.
So this will be, I want the rate of change to be 0, so for max or min.
Divide by 2.
I think multiply everything by this first.
Oh, wait, that's smart. Yeah.
So I get 0 is equal to minus 2x squared plus 2 times 100 minus x squared. That times that is going to be...
Sir, you can't divide by a factor, but you can multiply by a factor. Because like when you divide by a factor, you might like lose another x value.
If there's x in it, yeah.
Well, it looks so cool on the
But you
graph.
can multiply by a factor and it won't matter.
It shouldn't, no. Right, so we can probably have a go at this. I think we have it. You have it already? Plus 200 minus 2x squared. I think that's 4x squared is equal to 200. X squared is 50. X is equal to the square root of 50.
I got y equals 20.
Y is equal to 20. What's y?
You know, when I figured that when I put x equals 0.
X 0? We don't want x to be 0.
7.003.
Yeah, I'd leave it as root 50. That's okay. And that's it, done. Find the largest rectangle. Okay, so the largest rectangle then is going to be one of dimensions root 50 and what would it be here?
Root 50. Wait,
Yeah,
I
root-
don't
also
know.
root 50.
What? Wait,
Oh.
100.
So if root 50 goes in here,
Yeah, root 50.
2 root 50, yeah.
Wait, oh, 'cause
Y
it's
two.
the whole.
That's root 50. Root 50 squared is 50. 100 minus 50 is 50. Square root 50 is square root 50. And 2 of them because it's 10. Oh, we got there. This is the perfect one for that. There we go. We got there.
But isn't
Would
that
the
so
area be
cool, like, you can do
Would
that?
the area
Yes, it's calculus is finally becoming cool, mildly cool for one person in the class.
No, the volume is.
Aiden dreams about maths, so this is cool for him.
I dreamt about getting a bad math test. Last
Okay, that
is my reality?
I heard about getting bad tests.
who's gonna go next? You're gonna go next, and you're gonna do these two.
Who is gonna go next?
Yeah.